talking to a coworker the other day. He's got one of those circle track dirt burner 4-cylinder cars that basically, I guess I'm not sure what they are. I don't follow anything like that, but it's my understanding they just take essentially a stock 4-cylinder and throw it in these cars and build some sort of pipe roll cage and go around in circles and try and win. But I guess they all try to cheat to get a little bit of a heads up on one another. So they'll take these stock engines and they'll mill the heads, try to get a little bit more compression ratio and everything, so on and so forth. But anyways, he was telling me about how he kept blowing head gaskets. He's wondering why that might be happening. And just to kind of give you an idea of my background, my dad started racing in about 1961, 1962, and he always built all his own cars, front to back, engine, transmission, rear end, body work, so on and so forth. And I personally, there's literally pictures of me from 1971 when I was 3 years old at the races, standing right beside my dad while he was working on the cars. And as I grew up, rather than like most people are, just out playing, doing whatever, I was paying attention to what he was doing and learning right from the start. So sometimes I take things a little bit for granted that other people maybe don't know that are, this guy's probably in his mid to late 20s. And anyways, just kind of give you an idea how far back I go as far as racing goes. I'm 43 and I've been literally into it for 40 years. But anyways, I started asking him some questions on this. It turns out he milled the heads on this 4-cylinder. He's using a Dodge Neon, I think it's a 2-liter single overhead cam 4-cylinder. He milled the heads, and he'd also milled the block, and he'd get partway through the race and he'd blow a head gasket. He couldn't understand why. Well, part of the reason why is he's got way too much compression ratio, whether he realizes it or not. Those engines come from the factory at 10, half to 1. He's milling the block and the head both, so he's probably got over 12 to 1. Started questioning some. He's using regular 93 octane pump gas in this thing, so that's not helping. But also I started quizzing him on how he was torquing his head bolts, and he was really proud of himself. Well, I start from the center and work my way out in a crisscross pattern. I said, well, that's good. What kind of lube are you using on your head bolts? I get a blank stare. So, well, there's your first mistake. And asked him what he was torquing them to, and he was all happy. All 70 foot-pounds, he said, which I don't know. He says that's what's in the shop book. It may or may not be. I have no idea. But anyways, I said, well, how many steps you doing them in? I get a blank stare. And I said, well, you need to do it in 3 steps. You don't just take them right to 70 foot-pounds and move on to the next one. You got to start out. If it was me, I'd go 35, 50, and then 70. And you need to lube them. More than likely, the spec in the book is to use straight 30-weight motor oil. That's usually the most common lube for just standard shop use. Like if you're building a stock engine or whatever, that's usually what the specs are. So it got me thinking. The guy didn't understand how bolts work at all. It made me start to think that, really most people don't understand at all how bolts work. So I thought maybe I would demonstrate a little bit of something here. You can hear my dogs barking about something back there. Somebody's running up down the road with a 4-wheeler. But anyways, I've got my connecting rods here that I'm gonna put in the next engine that someday hopefully I get the money to build. And I just kind of thought I'd kind of give a little bit of an example of how these bolts work. And the connecting rod bolts are really no different than a head bolt. So this is just a good visual example. Basically, when you torque a bolt, what you are doing is you are stretching a spring. And depending upon the material that the bolt is made from, determines what you torque that bolt to and how much of a load it can handle. If you have, say, a 7/16 bolt that's a grade 1 bolt, you will torque that to a lower level than you will, or a lower torque spec than you will, say, a grade 8 bolt. And that grade 1 bolt maybe is only capable of stretching, say, that far before it reaches its reaching its yield point. And then after it reaches yield point, it'll either stay permanently stretched or eventually it will break. Whereas that exact same 7/16 diameter bolt, if it's a grade 8, whatever they are, I can't remember, 180 psi or whatever, I can't remember exactly, you're stretching it this far because you're torquing it at a higher level. Now that bolt can handle a much higher load. That's why you have different grades of fasteners, and there's a lot more to it than that. And you'll find in structural bolts, you don't necessarily want a grade 8 bolt. I'm not going to get into all the specifics of that. I might someday. But anyways, this is an example I always use for people. I try to explain what happens when you're torquing a bolt. Basically, your bolt starts off at this length, and then when you get to the correct torque spec, it's stretched to the distance that's a little bit before the yield point, and that's where you get your maximum strength of that particular bolt. Now, when you're doing a rod bolt, you have a certain spec, and usually you have a certain lube, which with these particular bolts, they're an 8740. That's the material. It's an ARP rod bolt, 7/16 in diameter, 1 inch 600 thousandths from the face to the end of the threads. So that bolt, using ARP's lubricant, which is nothing more than a moly lube, but I always use the ARP lubricants. This is what they specify, and there's different grades of moly lube. Some of it has more moly, less moly, thicker oil. Basically, whenever you torque a bolt, there's actually thread created, or heat created between the threads. And with motor oil, the motor oil will actually run away from the threads, whereas this stuff will stay in it as you're torquing it. So you always want to use a good assembly oil, assembly grease, if that's what your torque spec is too. These particular rod bolts, according to my list, 7/16, 1.6, 8740 cap screw, torqued to 63 foot-pounds with ARP moly lube. And that will give you a maximum of 5 thousandths of stretch. Now that's the maximum stretch that you want with that rod bolt, is 5 thousandths. Any more than that, and you're going past the yield point, and that rod bolt is going to stretch and stay there, or possibly even break. So you'll notice, and I'm trying to, instead of trying to hold this thing around and giving everybody see motion sickness as I'm doing this, I'm trying to hold this on a tripod, but I'm not a videographer, so it's not going to be very professional. But anyways, you'll notice I have each one of these bolts grouped in twos. There's a reason for that. I used my rod stretch gauge, and I came to find out that each one of these bolts from the factory are actually a different length. Well, that's just fine. Actually, I'm not very impressed with that. I might just buy another set of rod bolts to see if they have been too. I bought these particular connecting rods off of a guy that had a Coast High Performance stroker kit that supposedly nothing had ever been assembled, and everything was still wrapped up in plastic and everything, so I'm assuming it wasn't. But if it was, he may have torqued these bolts incorrectly, and if that's the case, then I don't want to use these rod bolts. But anyways, using my rod stretch gauge, you can see that using this as basically 0, that's my shortest rod bolt, which actually measures, if using my depth mics, measuring from there to the end of the threads, came out to 1 inch 601 thousandths, so that's not too bad. But anyways, that's my 0, and then my longest rod bolt is, let's see, that's not the longest one. I think it's this one, because I've got one that's really long. Yeah, this one's a little over 5 thousandths over. So this one here would, measuring from here to here with my depth mics, would measure 1 inch 606 thousandths. So okay, this rod bolt is already 6 thousandths longer than a 1 inch 600. So the rod bolts are only allowed to stretch 5 thousandths. This one's already 6 thousandths longer. I don't know whether that's manufacturing tolerance or whether that rod bolt has been stretched way too much. That's why I'm going to have to buy a new set of rod bolts. I think they're about $60, and well, $60 is way worth destroying my engine. So anyways, I have these all grouped up. These are the 2 longest ones, these are the next 2, so on and so forth. The reason I'm doing that is I can start off with my number 1 rod, and I know my dowel indicator set at 0 is going to be doggone near what the 0 point is for these length of these rod bolts. So when I torque that to the 63 foot-pounds, or what I usually do is I approach the 63 foot-pounds, I'll torque them to say 57, 58, and then from there on out I'll bring them in with a wrench to where I get, say, a 4 thousandths of stretch, a little bit less than the maximum stretch of that bolt, using the ARP rod lube. But then I can do these 2, and then I can go to these 2, and I can reset this up. So these ones will actually be, if I remember right, let's see here. Yeah, they're about 1 thousandths longer than what these ones are. So I can take that into account right down the line, so I can get an accurate stretch on those rod bolts if it turns out that the reason these are different lengths is because of manufacturing tolerances. And to tell you the truth, if these ARP rod bolts vary 5 to 6 thousandths from the factory, I'm not very happy with ARP for leaving the tolerances that wide. That's incredibly wide. But anyhow, what I do is I lube not only the threads but also the face, because there's a huge amount of friction on that face as well. If you don't lube that, then you're going to get a false torque reading. So it doesn't take a huge amount. It isn't like you have to really slather this stuff on, but what I do, it's kind of hard because you get a whole bunch of it on this brush, so you end up slathering on whether you want to or not. I always make sure that I push that right into the root of the threads. Notice how I'm pushing hard on that, and I come back around several times. That way I know clear into the root of the thread, that's that's going to be lubricating. Okay, let me grab one of these rods. That'll be for the number 1 connecting rod. So now I'll put a little bit of lube on the face there. That's really about all you need. Okay, thread that one in by hand, and then I'll do the same to the other one. Same thing, working that right into the root of the thread. If you just leave it on the surface of it, then when you screw that down in there, it can wipe off. Or get some on the face. I'm talking, not paying attention to what I'm doing. them in finger tight. Then I always, when I'm torquing these, when I'm checking, if you notice I've got my bearing insert in there. So I'm probably going to do it on camera probably because this is getting kind of long anyways. But I'm going to check for bearing clearance on those rods. But you'll notice I've got a connecting rod vise. I always use a connecting rod vise. If you don't, you'll end up very possibly twisting the connecting rod. So fit that in the connecting rod vise. I've already got the cap seated. It's already seated down as far as it can go. And I'll run this in. And I don't know if you can see how close that I've got that or not. I've got this tied to a cord at the moment. Let's see here. Yeah, this is great videography, isn't it? But anyways, notice I've got that as close as I can to the base of that bolt. And then I've got that torque fairly tight. Doesn't have to be super tight. This is aluminum, so you're really not going to hurt the steel connector rod. I'll run these in. And then off camera, since this is getting awfully long, I'll torque those bolts to 63 foot-pounds. Actually, what I'll do is I'll start off, say, like 35 foot-pounds, and then move to, say, 45 or 50. And then I'll stop short of 63. I'll go to maybe like 59 or 60 foot-pounds. Check my stretch, and then adjust from there until I have about 4,000 stretch on each one. And I'll be back and I'll share the results of that. Okay, I've torqued these rod bolts using 3 separate steps, 35, 50, and then I torqued them to 60 foot-pounds. I didn't go to 63. And interestingly, measuring the stretch, it is quite accurate. At 60 foot-pounds, it's kind of hard. I don't know if I'll be able to do this very well on camera. It's kind of hard to hold this centered on the bolt, on the nub, and then on the center of the bolt head. But I don't know if you can see that or not, but if I keep that centered there, it's actually about 4,000. So I don't know if you can see that on there when I have that centered, but it's stretched about 4,000ths, that one. And let's see here. This one here is also stretched about 4,000ths. So 63 foot-pounds using the ARP Moly lube, and with these rod bolts, it was quite accurate. And I know my torque wrench is accurate. It's, even though it's probably doggone near as old as I am, this is actually one my dad had. I've had my own for quite a few years, and it turned out to be a piece of junk. And this thing here is probably at least 40 years old and still going strong. And I test that at work. We have an actual torque wrench tester at work that's certified every 6 months, so I know this thing is correct. But anyways, I don't know if you can see that or not, but it's set at 60 foot-pounds, and that rod bolt is stretched 4,000ths. So you have the maximum clamping load on that rod cap for these bolts. You could go to 5,000, which is max, but I don't like to go to the max, absolute max stretch. I like to get as close as I can to the max. I could actually maybe put that back into the rod vise and adjust it to, say, 4,500ths. But when you're building the engine, that's awful hard to do. You can do it, but this thing here is kind of bulky and hard to get in the tight spaces when you're building an engine. So I know that if I torque these rod bolts at 60 to 63 foot-pounds, I should have the 4,000 to 5,000 stretch, which is exactly what we want. But anyways, getting back to the head bolts, you basically do the exact same thing on the head bolts, only it's really hard to measure the length of them. So you have to trust the fact that you have the correct amount of moly lube and that your torque wrench is correct and so on and so forth, which, this kind of proves that, yeah, it is pretty accurate to do it this way. But anyways, that's the suggestion I made to the guy at work, getting way back 20 minutes or more ago since I started this video, for torquing his head bolts. I didn't tell him to use the ARP moly lube, because if you do, you have to reduce the actual torque spec on the torque wrench by quite a bit. But I did tell him to go out and get straight 30 weight motor oil. That's what they usually use the torque specs on, and lube the threads, and then also lube underneath the head. Use the torque wrench in 3 different steps, and that should stretch your head bolt to where you need to go. Now, he's going to try it this weekend, and we'll find out, but I know for a fact that's right. I've never had any trouble, even with, we've had turbo engines before with no trouble, so it'll work.